Okay, yeah. My name is Matthew Angiagba, a veterinary assistant with the Immunity Veterinary Clinic. And we just want to welcome you to our episodes of discussion on the issue of anthrax. And we have a couple of people who will be discussing with us. Just in a little while, we shall be introducing them one after the other. It promised to be a very interesting session.
All right.
Just hang around.
My name is Dr. Charles Emeka, the resident clinician, Immunity Veterinary Clinic. I hope to use this platform to communicate to our clients and our dearly beloved viewers of one of the emerging diseases that is almost like a household name in our community by the name anthrax. Before I go properly to my discussion for today, let me give us a brief history of the disease anthrax. In the early 90s, that's the 20th century, precisely in 1914, this disease was used as a biological weapon by the Germans. They used the disease to combat their perceived enemy. Of course, during the World War I, the Germans fought with the Russians, the France, and its allies, and they used the disease to inflict their animals and also kill them. Recently, in 2011, that's after the 9/11, of course, the terrorist attack that affected the tower in the US that killed over 2,500 persons. History revealed that an unknown doctor started sending mails to people generally, and that letter mail, or more like a paper mail, has two contents: a letter that comprises of threats, and then a powdery-like substance, which eventually was discovered that powdery substance was anthrax spore. Eventually, before they could discover it, we've had up to about 22 persons who have been infected by that virus or by the bacteria, and about 5 mortality. Looking at all these antecedents that have happened regarding this bacterium, it is expedient that we discuss it, because how deadly this bacterium can be. I'll quickly go straight to my discussion, but I want to lay more emphasis on the pathogenesis of this disease, because of course I've seen so many discussions online, and I think on this regard they are actually weak. So I decided to spend so much time on the pathogenesis. Recently, yesterday or a few days ago, I was with a client, and then she was asking that is this anthrax real? I think this video will tell us how real this anthrax is, how deadly it is, and then the prevention and control of it. First of all, what is anthrax? Anthrax is a zoonotic disease that is caused by the bacterium Bacillus anthracis. When you hear the word zoonosis or zoonotic disease, it's primarily a disease of animal origin, meant to infect animals, but eventually could affect or infect humans. Now, this bacteria, Bacillus anthracis, have about 5 distinct characteristics that makes it totally different from the conventional bacteria that we have on ground. Of course, with the sophistication of medicine, handling bacteria shouldn't be something of so much of worries, but the distinction of this Bacillus anthracis has cast so much fear, caused so much dread to this bacteria. What are those 5 peculiar characteristics of Bacillus anthracis? One, we're told, of course, Bacillus anthracis, they are gram-positive, non-motile organisms. Secondly, this Bacillus anthracis has a proteinous wall. When I mean proteinous wall, I mean that the covering of this bacterium has more like a protein around it, unlike the conventional bacteria, which it does not have that peculiarity of a proteinous wall. But Bacillus anthracis has a peculiar proteinous wall that gives it a special edge against the conventional bacteria we have. Thirdly, it is said that this bacteria produces spore. Now, most people are hearing spore, spore, spore. How does it produce this spore? Now, just take a picture of a substance. Let's say, for instance, this is a pen. The size of the bacteria, of course, is not as long as this, but a bacterium, just have a picture of a rectangular shaped stuff like this, and then it replicates itself. Presents another size of this bacteria. Now, in season, when in dry season, when there is no water, when there is no convenient environment for it to thrive, what it does is that the parent bacterium, sorry about that, the parent bacterium replicates another one, which is more like a baby bacterium on it, and then that very bacterium on it now loses fluid, loses its shell, and then forms a keratinous substance around the body. That keratinous substance is what we call the spore. Usually at the end of that, the parent bacterium opens up and engulfs it, and then seals it in such a way that it has three protection. It has the proteinous protection, it has the gelatinous protection, and then its own protection. That gives it a formidable form that cannot be attacked by heat, cannot be attacked by ultraviolet ray, can also not be attacked by our conventional disinfectants. The fourth peculiarity about this virus is that its size. It is said that Bacillus anthracis is one of the most smallest bacteria that we have. The other conventional bacteria forms or ranges between 5 micrometer and above, but this bacterium has its ranges between 3.3 to 5 micrometer by length, and then 1 to 1.2 micrometer by width, making it one of the most smallest organisms you have. Please take note of these informations because I'm going to be using it to talk about the pathogenesis of this disease. Mode of transmission. How is this bacterium transmitted? I'll start with the transmission to animals. Most times animals fall victim because once they go to the grass during grazing and then come in contact with a grass that has been infected with this bacterium, innocently they pick up this bacterium and then they get infected with it. Now, talking about human transmission, when a person goes to let's say a farmer, for instance, take a farmer who goes to the bush to farm or goes to his farm to farm. In the process of farming, he comes in contact with a soil that has the spores of this bacterium. In the process of excavating, he excavates the spore of this bacterium, and when he does that, he might likely inhale the spore. As soon as he inhales the spore, that mode of transmission is called inhalation, and then that gives us the first phase or the class of this disease, which is called the inhalational form of this disease. Then the farmer could decide to go home. He decide to, on the process of farming, he could mistakenly injure himself with his hoe or his appliances that he is using, and then cause a debridement on his skin. The spores goes to that skin to patch. Through that point, the cutaneous form of this bacterium can be formed. Now, this same farmer goes home. He didn't remember to wash his hand very well. He just picked his food, maybe tuwo or whatever food he has, picked it and throws it into his mouth. He can get infected with the bacterium by injection. That is the injection or gastrointestinal form of this bacterium. Now, having said this, I'll quickly go to the pathogenesis. Just like I said in my intro, that I've listened to several discourses on this topic, and most of them are not they are weak on this pathogenesis. We just hear this, but we want to know how this disease substance causes disease condition in our body, because of course the meaning of the word pathogenesis is the process through which a disease substance causes a disease condition in the body. For instance, you have your malaria parasite, which is your plasmodium. Of course, you know how the plasmodium parasite causes malaria disease in your body. Now, before I say that, I'll need you to take note of this very point before we talk about the pathogenesis. Now, take note that this bacterium has four striking genetic materials. Now, genetic materials are actually substances that are found in the DNA of any cell. Just for instance, when you have a father that has a big head, giving birth to a son that have a big head. How that is made possible is because the father has a genetic code for big head that now was transmitted or transferred to for his offspring or his child that will then have the size of his head big. In the same manner, this bacterium has four genetic codes in the DNA of its cells that give it its peculiarity. And the first genetic code that it has is that proteinous wall I made mention initially. The second genetic code or genetic factor that I had is an edema factor, which I will be talking during the course of the procedures of the pathogenesis. The third genetic code is the lethal factor, and the fourth genetic code is the protective factor. Now, let's discuss the pathogenesis. When an animal that has these diseases, maybe in the wild, dies, over time, the carcass starts decomposing. You have animals, scavenger animals coming to eat up this carcass and then walls of the carcass. Eventually, the bacterium has no media or no host to stay with. The bacteria is now expelled to the environment. As soon as it senses a harsh environment, what it does is that, just like I mentioned earlier, it starts sporulating, it forms spores, and then that spore can stay on the ground and in the grass for as much as 40, 50, 60 years, for several decades. It stays on the soil. Now, an innocent farmer or an innocent animal passing through that place decides to graze on that plant that is there. Innocently, he picks up the spore. For a man, he picks up the spore. For the animal, he chews it up or whatever means that is going to be infected. Now, once the spore gets into the respiratory tract, it passes through the nares, that's the nose, gets to the pharynx, gets to the larynx, it passes through to the larynx, through to the trachea, and then goes to the bronchi. Now, the most conventional bacteria, because of the size, they don't cross the trachea, the bronchi of the respiratory tract, because of their size. The bronchial size is so small that they can't cross through. What eventually happens is that they are expelled out. But for this Bacillus anthracis, it's so small that it can find its way down to the alveoli of the respiratory tract, right there into the lungs. And then right in the lungs, people usually think that it causes its problem in the lungs. No. Even when you check, you want to use your ultrasound, you see that most of its pathological issues or pathological lesions will not be seen in the lungs. That is what even makes it more deceptive. What happens is that right in the alveoli of the lungs, the organism starts mutating, starts changing its spore forms to bacterial form. Of course, the body immune system sees it as a stranger. So the body immune system has to send some soldiers to the alveoli, particularly the macrophages. Now, the macrophages, which is of course the soldiers of the body, goes to the alveoli and then sense that, okay, all right, I have bacteria here, I need to come and engulf. And then the macrophages goes in an attempt to engulf this bacterium. What he sees is no longer business as usual. One, he comes in contact with a bacterium that is having a proteinous wall. He tries to engulf the bacterium escapes. He does his best to engulf like 50% of this bacterium, and then the other ones he can't, just because of the gelatin, the proteinous wall. Then, right in the cytoplasm of these macrophages, the macrophages, in his usual way, usually releases an enzyme called lysosomal enzyme. This lysosomal enzyme, what it does is that it makes the environment acidic so that it can kill the bacterium. But this time around, unfortunately for him, when he tries to make the environment acidic by releasing those lysosomal enzymes, what happens is that the bacterium becomes more active than the normal, beyond against the expectation of these macrophages soldiers. Then what usually happens is that the macrophages has to go back to the lymph node. It's like soldiers who went to war front and then discovered that the battle is so much for them, so they have to report back to the barrack. The macrophages picks this bacterium and then serve as a wall to return it back to the lymph node. That is why it is said that Bacillus anthracis or anthrax is usually a disease of the lymph nodes. Okay, so he goes back, he runs back to the macrophages and he runs back to the lymph nodes. On getting to the lymph node, he gets there and says, hey guys, we have something new here. Take a look at this. And then when he gets to the lymph node, other macrophages, on coming to look at what is happening, he kills that macrophages and invade another macrophage. And then from there, it causes necrosis in most of those macrophages. The aim is not to invade the macrophage. The aim is to invade the cells of the epithelial tissue. So what he does is that after he has finished killing all the soldiers of the body, causing a generalized immune suppression, he then goes to the body cells. One of his predilection sites is the endothelium of the blood vessel. Now what it does, remember the factor I talked about, the lethal factor, the edema factor. Once it gets to the endothelium of the blood vessel, it kills the cells, releases the fluid. That is what gives you the edema that you see in cases of anthracis. And then over time, it causes hole, like a puncture hole around the blood vessel. Eventually, you see that the blood will start leaking out. That is usually the blood that you see oozing out from the nose, the ears, and all parts of the orifices during anthrax condition. Eventually, the animal dies of shock. Not the Bacillus anthracis that kills the person. What kills the person is the hypovolemic shock. Because eventually, once there's a leakage in the blood vessel, there's shock, and then the animal dies. Lastly, I will conclude by giving us the prevention and the control. I separated the prevention and control into, made it very easy for us, A, B, C, and D. The A is avoid all sick and debilitating animals. Once your animal is sick, it's not your responsibility to treat the animal. You get a vet, get an animal scientist that can handle your animal. So the A of it is, please don't forget this acronym. Avoid, totally avoid. There are other good alternatives to meat that you can use. The fish is there and whatever. The B, the acronym B there is best. All right. I said A, of course, you avoid the eating the animals, and then the C is your cleanliness. The C, you have to be careful with your cleanliness. Most times people go, they are not careful with their hygiene. They just mess up around and then touch these things, and eventually they get down with it. So be careful with your cleanliness, your hygiene, and what have you. And then the D there is the usage of the derived vaccine. There are derived vaccine from bacterial spore that is available in the market. At this point, I would say you get your vet, animal scientist, or whoever that is close to you to ensure that your animals get the right vaccine, and then make sure that at the right spot, the proper check, surveillance, quarantine, and proper animal check is done at the abattoir and in the farm where your animal is. If all these procedures are properly done, you would hardly come in contact with this deadly bacteria. All right, I hope this video has enlightened somebody or someone out there in a good faith. Thank you for watching.
Wow. This is actually very, very interesting. You have exhausted. I'm just level we are starting to learn and you are fresh, and then you have actually given us detailed information of what we need to know. I mean, every other person listening or watching this video will definitely learn something from it. Now, just a few couple of questions, huh?
All right.
Particularly, what is the take or what's the way forward? I heard you made mention of the abattoirs. I mean, the appropriate authorities that are saddled with the responsibility of inspecting our abattoirs and those that will want to actually say this meat is wholesome for consumption, is fit for consumption. And where an animal is sick and these authorities go ahead to condemn that particular animal, is there a place for these authorities to compensate these meat sellers or these farmers?
All right, that's a good question. Even though this has lingered for a while, it has been a burden in this part of the country because we have most farm cattle owners not getting compensations from the government, and then you can't expect them to just kill their sick animals because they know that if they do that, having access to this compensation fund is not really available. Even though discussions are still ongoing in that regard to ensure that we can talk to the government and talk to our own government to see how we can make funds available for compensation should in case there is an outbreak or issues like this. They will be comfortable to call their animals and then go to government to get compensation.
I think that has always been the most response we hear for vet practitioners and even government also will say. So we just hope that this will be reviewed and the
That's
proper
true.
thing being done.
So
And
true.
because most times you find the meat sellers or the abattoir fighting with the
Fighting.
vets and the abattoir for the infection. Some, if you are not careful, you even get injured
Of
because you're
course.
trying to defend or protect your own resources, so to say.
Of course.
So, are there any questions from everyone? Okay, answer. So, and then just one that just came to mind. This and the urban areas where we have this information, one can just go through your video and easily pick this information,
That's
get learn that you have this information. But another body here, most of our brothers and sisters in the interior villages that do not have access to this kind of facilities that we have that we go through all this information. What now happens to them? How does this information get to them?
All right, it's a good question. If you look at the chart of or the chart through which diseases are being reported or diseases have been harvested in a community, there's usually a set of people that comes close to the rural people. These people are called the community health workers. Now, we have community health workers that comprises of vets, vet assistants, and of course, animal scientists and technologists. Now, these guys are available. What they need is mobilization and fund. The moment they are properly mobilized and they are funded, these guys they come in contact with those old women, with those old small children. They know the villages. What they do is that they go there, enlighten them, one-on-one discussion, organize little seminar, just little gathering, and then talk to them on this disease and the how deadly this disease is and how to control it. So the advice here is it's to mobilize these persons and then send them into the community, and then we'll get this job done eventually.
So just again, the little one again. I heard you made mention of how tough and how this virus, this bacteria, and how it's able to withstand heat. I heard somewhere in Africa they said anything that goes to fire does not come back the same again. Are you trying to say that even with the firewood kind of fire, after cooking this meat very well, that this bacteria still survives?
Yes, I think I mentioned, anyway, for emphasis purpose, but I mentioned it during my intro, that this bacterium has been so sophisticated that it withstands the heat. For instance, I said that the bacterium would eventually, during the spore formation, it forms a gelatinous wall around, a keratinous wall around its cytoplasm. Then that wall, with including the wall of the parent, which is the mother, which is proteinous, that it invade inside, gives it a very tough skin that is resistant to heat, resistant to ultraviolet ray, resistant to the natural disinfectant or the conventional disinfectant. So no matter the strength of heat that you use on it, you can't degrade the spores. The spores are so sophisticated that they repel the effect of heat.
Wow. Wow.
Thank you so much for this wonderful lecture.
Thank you, Doctor. Thank
I
you,
want to
Doctor.
ask, what's the incubation period? Hunting, the one
Yes.
eating that infected.
All right, that's a good question. The incubation period usually varies. Now, for the cutaneous form, that's infection through the skin, it is said that the incubation period for cutaneous form is between 2 to 5 days. So once it gets to your skin, it starts manifesting the clinical sign in 2 to 5 days. Then for the respiratory form, the incubation period is from 19 hours, so less than 2 days. You start seeing manifestation, even though some take as much as 5 days and beyond. While that of the GIT, the gastrointestinal form, takes falls between 2 days to 14 days. So within this period, you will see the manifestation of this sign. But one thing is certain: once you're infected and you don't do anything about it, you will see the symptoms.
What are the symptoms?
All right, even though I said for the sake of this video, I was going to spend so much time on the pathogenesis, but however, since that question has been asked, the symptoms is dependent on the form that we are seeing in that animal, in the human. If we are dealing with the respiratory form, you will see respiratory related symptoms like your chills, your sneezing, your coughing, any signs that is related to respiratory distress. You will get to see all those signs. Now, if we are dealing with a cutaneous form, just like I said, this bacteria goes to the lymph nodes within the skin or within that organ that is affected to attack. Now, what happens is that if you are dealing with a cutaneous form, it goes to attack any lymph nodes around that skin, then eventually starts causing necrosis, and then eventually you start seeing ulcer within that area, which much later you see mild pain ischias. From necrosis to ulcer to ischias. Usually that ischias, you won't feel the pain, it's painless, but the sore is around it. Of course, for the GIT stage, the GIT form, the gastrointestinal form, you see diarrhea, you see vomiting, and all manner of things, because the organisms has gone to the lymph nodes around the GIT, basically the Peyer's patches, and then attacks the lymph nodes and causes GIT symptoms.
Thank you very much, Dr. Charles. It's been a wonderful session. This you will not understand, but it's very powerful. Those people who know English, they say it's powerfully packed. Thank you very much. We'll bring to you again, Dr. Charles, as we continue to unveil the episode of Anthrax. Thank you very much.
All right, thank you.